All right, so to get started today, I want you to discuss and review this vocabulary. We have used these words a lot in our previous lessons, but we haven't officially defined them. With how we have used them, you still should know the meaning of each one. So discuss with your groups. Pause the recording so that you can reflect on the meaning of these. Ready, set, go. Where's the brave souls who want to tell me what they think an expression is? Maybe. Go ahead, Chandon. Just expression. No, expression first. Yeah, mostly. Tad. Yes, I'm hoping expression. Do you know expression? Good guess, but not quite. Last guess here, Gavin. Okay, good guess. I haven't heard any real correct answers. What is an expression? An expression is a math sentence. No, it's not. That contains numbers, variables, and operations. Operations, first thing you need to understand, operations are just addition, multiplication, subtraction, division, right? So if I have numbers and variables, how are they related? With addition, or with multiplication, or with subtraction. I don't have any examples that include division, but that could be there as well as many other operations. So what is an expression? I'm just going to keep these brief. An expression is a math sentence. Nope, an expression is a math sentence. This was officially defined for you in Utah Middle School Math Project 1.1a. So you should know because we did already discuss, but that's okay. An expression is just very simply, it's a math sentence. Okay? What is an equation? Anyone brave enough to share? What is an equation? Okay? I know, but you had a chance, so I'm going to call on other new hands. We can always try and come back. Katie. An equation is an equation? True statement, but it doesn't really help me understand. Okay. Good guess, not quite. Good guess. Let's go to Jackson. You're kind of. You can solve an equation though, and the equation when you get the answer like x equals 4, that still is an equation. So you're at least thinking in the right direction. Last guess, we're going to go to Gabe. Nope, that would be more accurate of an expression. An equation is, here's the official definition. Oh, maybe? Just kidding, it's not here. The official definition we are going to highlight. Equation is officially defined in our very next lesson that we are doing today, which is 1.1c. An equation is a math sentence with an equal sign. You should know that because what is the root word of equation? Equal. So it's a math sentence with an equal sign. There is more, but that's the gist of it. So an expression is just a math sentence. An equation is a math sentence with an equal sign. So for example, we could have the expression 2x minus 7. We can turn that expression into an equal sign, not just by saying 2x minus 7 equals, but 2x minus 7 is equal to, we have to balance it with something else. So let's say 2x minus 7 is equal to 39. Now we turned that expression into an equation because now it has an equal sign and it's balanced with something else. Do you see the difference between those? Okay. Simplify. Who thinks they know what it means to simplify? We have been doing a lot of simplifying, so I hope we've got some good answers here. Luke, what do you think? Yeah, basically, yeah. Simplify means we're going to make the problem easier and simpler. I do think I have simplify. Just kidding. I don't have it necessarily, but I do say a numeric expression can be simplified to a single number by doing the things that it says to do, by making it simpler, as Luke said. So for example, 4 to the second power minus 7 groups of 5 plus 3, we could do 5 plus 3 is 8. We could do those 7 groups. We could do the 4 to the second power. We can do all of these things. And doesn't that equation look simpler and simpler and simpler every time I take another step? Okay. So yes, that is exactly what it means to simplify. Now typically, once we're past like 6th grade, we don't do numeric expressions. Numeric expressions are number sentences, or excuse me, math sentences that contain only numbers and operations. We, in junior high, focus more on algebraic expressions, math sentences that contain numbers and variables and the operations, but those can still be simplified. That's what we've done with our algebra tiles. We start out with something big, we simplify it by combining those like terms and make it easier to look at. So yes, simplify really truly does make it easier to look at. Really, mathematically speaking, we would be combine like terms. You could even say get rid of parentheses, like doing our groups or our distributive property. We have been doing a lot of simplifying. Okay. Solve. What do you think solve means? I see hands, but as soon as I still see a fresh new hand, I want to try and call on that fresh new hand, and then I can go to hands that I've already called on. Let's start with Brian. What does it mean to solve? Yes, but also not fully mathematically correct. It does mean that we're finding an answer, but we only can solve equations. We're going to say equations are solved. So what I mean by that we could solve this equation by figuring out what x is equal to. So equations are solved. We find out what value makes the equation true. Now the ways that we do that can differ. Usually what I like to do is I like to make a flow map, even if it's just a mental flow map. What's happening to x so that we can undo it. I undo subtraction with addition. I undo multiplication. Did I say something weird? I feel like I said something weird. I thought so. Shush. I think I said something wrong, so I'm just going to repeat saying it correctly now. We undo subtraction with addition. So I added to both sides. Then we undo multiplication with division. And I solved. I now know that x is 23, but what that really means is I can just take that 23, plug it back in, and it makes this true. That's what that means. So solving is usually a process that we go through in order to figure out what the variable is that's going to make it true. Okay? That's different than simplifying. So let me make sure you understand the difference between these two. Simplifying is combining like terms. So like 2x plus 7x minus 9. I'm going to go ahead and put a plus 3 at the beginning. We can't solve this. We can find an answer because the answer to a simplified problem is really just combine like terms and show me what it looks like in a nice, simple, easy way to look at. That is an answer to the question, but it's not solving. Does that make sense, Brian, why it's find an answer to the question doesn't always work? Because we can always find an answer. It's just solving is a specific thing that we would do. Does that make sense? And evaluate. We also talked about evaluate in 1.1a. Who knows what evaluate means? Only one hand for this one. Okay, Dakota. Not quite. Again, you're not wrong, but you're not really telling me what evaluate means. For the sake of time, I'm going to call on just one more hand. Trinity, who actually went to 1.1a to look it up. Yep. We wrote this down. Substitute a number for a variable, then simplify. I do have an example of that on another screen, so I'm going to move forward to that one. Evaluate an expression. A specific value for a variable is given, then substituted in the expression, which is then simplified. So here's an expression, x plus 4 minus 4x. And I'm saying evaluate if x equals 2. So now, instead of x, that x becomes a 2. Remember when we did this? We substituted in, and then we simplify. 2 plus 7 minus 4 times 2 is 2 plus 7 minus 8, which simplifies to 1. All right, that's what it means to evaluate. And we do need to know the difference between each of these. This is part of the reason why students who struggled on the quiz, why they struggled. Because they tried to treat expressions like equations and they tried to solve them. Or equations tried to be simplified like expressions, and it just didn't work out. So we do need to know the difference between these. Okay, so what we're going to be doing today is 1.1c from Utah Middle School Math Project, solving multi-step linear equations. Now, these are multi-step because, and you'll see when we get a little bit further on, but it does, again, it reviews a lot of those same equations, or vocabulary terms that we had to go through to really make sense of all that we're doing today. In lessons up to this point, we have been working with linear expressions. That's partly true. I've done some other things with you, so you guys have also done some solving of equations. But we reviewed how to simplify a linear expression. That's combining like terms, doing the distributive property to get rid of parentheses, and how to evaluate a linear expression for the given value x when we substitute a value in for x and simplify. We will now begin our work with linear equations. Equations are solved. So when we solve a linear equation, our task is to find the values of the unknown that make the equation true. We just summarized all of this in our previous page, all about the vocabulary. So we are solving equations. These are going to be multiple steps. Damien and his friends went trick-or-treating. The next day, they got together and counted their candy. Damien had twice as much candy as Nick. Bo had 10 more pieces than Damien. And this is a model that represents the amount of candy the boys had together. We have a model and we have an expression. It says, show on the model and the expression which pieces represent the amount of candy each of the boys has. So let's read it again now, paying attention to the model. Damien has twice as much candy as Nick. When you see this model, do you see how it's got one group together, and then these two grouped together, and then all of that grouped together? So what do you think that means? Damien has twice as much candy as Nick. Birdie, what are your thoughts? Yeah, each one of these is going to be a new person, right? So what's this one going to be? Keyword here, Damien had twice as much candy as Nick. So who's that going to be? Nick, exactly. Which means the next one that groups a C and a C together is going to be Damien, because Damien had twice as much. And then Bo had 10 more pieces than Damien. So look, here's what Damien had. That's the two C's, but an extra 10. So this is what Bo has. We can see the same information with the expression as well. Where we have C, that is going to be Nick. we have 2C, a C and a C again. That's going to be Damien. And the 2 C's plus an extra 10, that, in parentheses, is what Bo has. So just two different ways of seeing the same information. But what if we also knew that together the boys have 230 pieces of candy? It's the exact same model, right? So it's the same model, only now we know that that whole entire bar represents the total amount of 230. C plus 2C plus, in parentheses, 2C plus 10 and 230 are both linear expressions that represent the amount of candy that the boys have. When we set two linear expressions equal to each other, we create a linear equation. A linear equation is an assertion or a statement that two linear expressions are equal to each other. That is so incredibly important. I am going to be asking you a test question. It is important that you know this. In summary, it's all right here. What is an equation? It's an expression that is equal to another expression. When I have an expression equal to another expression, that is called an equation. Going back to the beginning, you can see how I tried hinting at that. An expression is just a math sentence. An equation is a math sentence with an equal sign. So it's a math sentence equal to another math sentence. We can see that here, tying it all in together to that model. We still have our C plus 2C plus 2C plus 10. And we're saying that amount, that expression, is equal to 230. So an expression equal to another expression. This is a big expression that needs to be simplified. This is a very simple or already simplified expression. It's just a number. But even just a number can still count as an expression. So what I want to do, it says model the equation with your tiles and solve for C. I don't think that we need to model it with the tiles. I think this is a pretty good model here already. I don't think we need to redraw anything. And even this already shows that it's simplified. C plus 2C plus 2C plus 10. What do we have altogether? 1, 2, 3, 4, 5C. But that's not all. I have 5C and the extra 10 pieces of candy. And that's equal to 230. Notice what I did. My first step, even though it was an equation, I didn't do any solving steps. I simplified this first. C plus 2C plus 2 more C is 5C plus the 10. And now we can solve. What's happening to C? How am I going to undo that? You can see C is first multiplied by 5 and then we add 10. So I'm going to subtract 10 to start. And that gives me 5C, which is equal to 230 minus 10, 220. We're not quite done. We now need to undo the multiplication by dividing. And we have C is equal to 220 divided by 5. You all have calculators. And you get what, Birdie? Very good. So C is equal to 44. But let's go back. What does C represent in this context? The answer is already up here. What does that C represent? How much candy Nick has, exactly. So C is how much candy Nick has. That's perfectly fine. They're your notes. You do what makes sense to you. And if that's being a little bit lazy, that's perfectly acceptable to me. How many pieces of candy do each of the boys have? Again, look at our model, and our earlier expression can be really easy. Nick is C, so Nick has 44. How much does Damien have? 2 groups of that, right? Which you know is 88. So Nick has 44. Damien has 2 groups of that, which is 88. And Bo has, yeah, 98, because we look again, Bo has what Damien has plus an extra 10 pieces of candy. So Bo has those same 88 plus an extra 10 for 98. And one last vocabulary word to highlight. I think it's one last one. A solution to an equation is a number that makes the equation true when substituted for the unknown. In the above example, the solution is 44. It says verify that when we substitute 44 in for C, the equation is true. We know it is because we solved it, but verifying is checking our answer. When we verify, that's when we check. And it looks like this. We go back to the original equation, which was C plus 2C plus 2C plus 10 equals 230. But now instead of C, I'm using 44. So 44 plus 2 groups of 44. Pencil should be moving right now. Plus 2 groups of 44 plus 10 should all be equal to 230. And you have calculators that can help you out with this. But when you're at home, you probably don't have those calculators anymore, so we should still know how to do this. 44 plus 2 times 44 is 88. Plus 2 times 44 is 88 plus 10 is 98. And is 44 plus 88 plus 98, is it really equal to 230? Yeah, it is. It checks out. That's verifying. Okay, this part right here, do you remember when we did our chocolate anchor problem? Our chocolate problem reminded us that there are different types of solutions that we can now have. We can have one value, like there's 12 chocolates in a bag. There can be no values, meaning that was no solution, it was impossible. Or we could have had all values, where we could have had any amount of chocolates in a tub. But I want you to understand that for this section, for the first several lessons, we're only going to be studying equations that have one solution. So I gave you a preview that we're going to have different types of solution in the future, but we're not quite there yet. So all of these are going to have one single solution. I think I'm going to pause for just a second and insert a blank page here. I want you guys to really, truly understand what's happening, because this is where students in past years have gotten confused. What is an equation? We talked about it, we highlighted it, we wrote something else. Will you please discuss with your group, what is an equation? Ready, set, go. Okay, and I heard some good discussion. Yes, an equation is a math sentence with an equal sign, but it's not just saying, okay, here's an expression equals blank, right? So we're adding to our original thing, and equation is an expression which is equal to another expression. That's the key thing here. Eyes on the screen. Expressions are simplified. Okay? Just like this expression over here, if it's not already simplified, we can simplify it. So remember that. An equation is an expression equal to an expression, but expressions are simplified. With that in mind, let's now take a look at this problem here. It says the following is a model for this equation. 5x minus 8 minus 2x equals 4. Will you please fix this? I don't like that it doesn't do this automatically. We've seen models like this before. We've done a lot with models like this before, right? Here's what's different. It says 5x minus 8 minus 2x is equal to 4. So we now have one side and we now have a second side, and we need to show that they are equal. Please add an equal sign right there to show that this side is equal to and balanced with this side. Okay? And let's make sure that we can make sense of this. This is 5x. So we have 5x tiles here, right? And then it says minus 8. How do I show minus 8 with algebra tiles? Plus a negative 8. So I've got all these negative 8 unit tiles. And it says minus 2x. How do I show that? Plus a negative 2x. So I've got these two negative x tiles. And what would we do when we were simplifying expressions? Not even solving. When we were simplifying expressions, what would we do with this information? Chandon? Yeah, we would look for those zero pairs. We would combine the like terms. So these x tiles over here, I would pick up, move over here with these x tiles. Oops, not like that though. Yeah, that's one way to not do it. We're going to lock that in place and try moving these. That's going to zero out that positive, and that's going to zero out that positive, right? So that's the first thing that we would do. Now, I can't pick them up off of my page any more than you can, but we know that this and this are going to zero out. This and this are going to zero out. What do I have left after I zero out those zero pairs? 3x, exactly. I have 3x. What else? And 8 negative unit tiles. Exactly, which are equal to these 4 positive unit tiles over here. Yep. But all we did, Chandon, is we just looked at just the left-hand side. We just simplified on the left-hand side, and now we can acknowledge that now it's an equation that we can solve. But the first step before we even try solving is we have to simplify. Raise your hand if you have become a fan of making flow maps when you're solving equations. Yeah, just about all of you. What would happen if we didn't take this step? And we look at this and we see 5x minus 8 minus 2x equals 4. Can you make a flow map here? What's happening to x? Are you sure? I also see x is multiplied by 2. So how are we going to make a flow map showing it's doing both of those things? And the key thing is, you can't. We can't make a flow map when x is in 2 different places. Which is why our first step before we can make flow maps is we have to simplify. Going back to this slide. If an equation is just an expression equal to an expression, then our first job is to make sure that each side is simplified. Was it simplified in the beginning when I had terms that were needing to be combined? No. Is it simplified now? Yes. So what was our first solving step? It says solving actions. First thing is we're changing subtraction to adding a negative. When I do that, that allows me to move these x tiles and those x tiles closer together. 5 x tiles and 2 negative x tiles will combine together to be 3 x tiles plus a negative 8, which is equal to 4. Now, I'm going to switch gears for just a second. I've talked about this a lot. Now that we've changed our subtraction to adding a negative, if I would like to, and I do encourage you to, you can change your adding a negative back to subtraction. Can you make a flow map of this now? Yeah, because what's happening to x? Multiplied by 3 and then subtract 8. So we can make our flow map now. We couldn't before because what's happening to x? Which x? There's multiple x's, right? So which x? Now we have x in just one place. So what's happening to x? Now we can decide. Solving steps, we're going to start by adding 8 to each side. And then we'll divide each side by 3. Adding 8 leaves me with 3x, which is equal to 4 plus 8 is 12. Divide each side by 3, and we get x is equal to 4. Verify the solution. Whenever we verify, remember, verify, as we saw over here, oops, right here. Verify means we check our answer. Whenever we verify, whenever we check our answer, because we have multiple steps, I always want us to go back to the beginning. So the beginning was 5x minus 8 minus 2x. Only instead of x, now I'm writing 4. So 5 times x becomes 5 times 4. Minus 8 minus 2 times x becomes minus 2 times 4. If I've done everything right, it should be equal to 4. So I'm asking, is it equal to 4? You have calculators, but let's go slow. 5 times 4, 20. Minus 8 minus 2 times 4, 8. I'm just taking care of the multiplication as part of the order of operations. 20 minus 8 is 12. And 12 minus 8, is 12 minus 8 equal to 4? Yeah, it checks out. So we verified our solution. That's all that we have time for. So your homework today, I want you to do 3 and 4. It says model and solve these equations. Do that so that we can start tomorrow by checking those answers. Thank you for watching. Have a great day.